Hi everyone, my name is Lydia and this is what I wish they taught me about econometrics and introduction. In the previous video, we explained the logic of testing a single coefficient, and now we're ready to make a decision. So in this video, we'll do exactly that, and we'll use what we will call the critical value approach. This is the most visual and geometric way to run a t-test, but in a separate video, we'll also show how to conduct another approach of running a t-test by using the p-values. So for now, because we're using the critical value approach, think of these as the video in which you're answering the question, is this estimate too extreme? Without further ado, let's move to the steps. The first step is state the hypothesis. So every hypothesis starts with the two competing statements, as we've said. The null hypothesis, which is always that some beta is equal to 0. And then you've got the alternative hypothesis, which is the most common one, beta different from 0. We'll see in another video what does it mean for us to have an alternative hypothesis where we see the beta either bigger or smaller than 0. But for now, let's stick to this bit right here. These hypotheses must be chosen before looking at the data, okay? Because this will also define what extreme means and on which side of the distribution we will look where that extreme is. Step 2, computing the test statistic. In the previous video, we showed a very generic way of writing the test statistic, which was your value minus the null value divided by the standard error. Now, when we are computing a t statistic, so this t is equal to whatever beta estimation you have out of your regression minus. Now, look very carefully. In the null hypothesis in here, we have that beta is actually equal to 0. So we're going to put here 0 divided by the standard error of beta hat, which usually will be given to you. One side note, most of the times, because the null hypothesis is beta equal to 0, you'll see a lot of books or maybe your lecture notes or seminar notes that this part right here is skipped, which makes sense because you are simply subtracting 0. So if you see that, this is what is going behind the scenes. Otherwise, the full formula is beta hat minus, so beta, what you estimate, minus whatever is stated in the null hypothesis, which means that if your null hypothesis in here was beta actually equal to c, to some constant c, then this 0 needs to be substituted with c in here, okay? And again, the interpretation for this formula was that this number tells us how many standard deviations away from 0. Okay? This is a distance, not a probability at this stage that we are in step 2. The next step, and that's why I've put it so close to step 2 as well, is once you calculate the t statistic, make sure that you continue this by also putting the distribution of these test statistics. So step 3 would be identify the reference distribution, or basically know the distribution. Under the null hypothesis, and which is why most of the times in some of the textbooks, when you see this sort of notation, you'll see here written under H null. So under the null hypothesis and assuming the conditions for inference hold, which means here the Gauss Markov conditions, these test statistics will follow a t distribution. But remember, for t distribution, we also need to put the degrees of freedom. In this case, this specific number of degrees of freedom is going to be n minus k minus 1. Okay? This distribution tells us which distances are common and which are rare. This is why step 3 is so important. Step 3, at the same time, will also dictate what comes in the next step. Step 4, find the benchmark based on the specific level of significance. So now that we know the distribution, I'm going to put this up a little bit. So now that we know the distribution, we have to find this benchmark. This benchmark, for some of you, is also called critical value. Okay? Now, we're going to get another t-value. So how do we make sure that we're not mixing up the critical value with the test statistic t-value that we computed? The most common way of writing it is by adding a star to the value that you are computing yourself. And at stage 4, where you are finding this critical value, you write t critical. This is the most common symbolism out there. And at the same time, for the benchmark for this critical value, because we need a specific level of significance, it's also associated with a subscript here by saying either a 1%, 5%, or 10%. If, let's say, you have an exercise and you have 5% as your level of significance, you have to make sure that you use that. If, let's say, you are not specified which level of significance you should be using, then in an exam, especially, make sure that you write, I will be using, very explicitly, I will be using the 10% level of significance, which is why t critical is equal to this, okay? So always make sure that you specify the level of significance if that level is not given to you. Okay. So once we find this critical value in the actual t-table, and now you also have a video that shows you how to read and find numbers in the t-table, that is going to serve as your cutoff. That is going to separate typical outcomes from extreme ones. Okay, so because again you are looking at the t-table to find the t-critical value, so the 3 elements, or the most 2 important element that you need is the significance level, so that you know which column you're looking into in that. And then you also need the degrees of freedom so that you know which row you're looking into the t-table. Once you have an intersection of the column and the row, you will find your t-table. Before, I kind of slipped and I actually said 3 elements before correcting myself, and that is because I didn't indicate in step 1 what kind of test I was doing. However, as you now know how to read the t-table, you know very well that actually there's another dimension in the t-table, and that is one-tailed or two-tailed test. And of course, this needs to be also taken into consideration. Whether you have a one-tailed or a two-tailed test gets decided right away in step 1. In step 1, if you remember, I put a star in here for the alternative hypothesis. Depending on what your alternative hypothesis is, you are deciding whether you are in a one-tailed test or a two-tailed test. The rule being that if your alternative is simply that it's different, then you have a two-tailed test. And if it's bigger or smaller, you have a one-tailed test. So now that we know all the 3 important elements, you can find your t-critical. Once you find the t-critical, step 5 and 6 come one after the other, making a decision and obviously interpreting the result. The decision rule is quite simple for this approach. If the absolute value of the t star that you computed in step 2, okay, is bigger than the t value that you find from the critical value, okay, then you will reject the null hypothesis. However, if the t star in absolute terms is smaller than your t critical, then your rule is that you fail to reject the null hypothesis. And I emphasized fail because you should never say, I accept the null hypothesis. You'll be very, be looked or frowned upon by saying accept. So make sure you make it a habit and say fail to reject the null hypothesis. Okay, so in here, we are literally comparing the distance to a predefined cutoff benchmark, nothing more. Interpretation. If we are rejecting the null hypothesis, then what we are saying is that the estimate is too extreme to be explained by randomness alone, okay? Which is also equivalent to saying that your beta is statistically significant, which is also equivalent to you saying that there's evidence that your beta head is statistically different from 0. Okay, so any of these ways of interpreting your result is acceptable, which means that now when we say that we fail to reject the null hypothesis, what we're saying is that the estimate is well within the randomness or within what the randomness could generate. Okay. Or equivalent to saying that the beta head is statistically significant, or all over again saying that your beta head is statistically not different from 0, or you could even say that there is not enough statistical evidence that it is far from 0. Okay? Keep in mind, neither outcomes prove truth or falsehood. So they just reflect the evidence under the level of uncertainty that you are facing. This critical value approach decides whether the estimate is too far from 0 to be plausibly explained by the null hypothesis. These are the steps. This is the intuition. In the next video, we'll run the same test using the p-value approach. So we'll do all of the steps for the p-value approach, and then we'll have videos with some concrete examples so that you also understand the differences between the one-tailed and the two-tailed test. I'll see you in the next video.